Week what we're working on here. Really don't want to talk over people. This week we're working through, let's see. Today we're going to work on some word problems, some modeling, some very simple stuff. I'm going to show you some tricks with the calculators to help you get through some stuff. It's going to be a combination of about 3 different sections of things that we looked at last week. You're just doing it a little bit differently. A lot of it with calculators. And with that being said, we'll kind of tie everything back together, review some junk tomorrow, and then I'm going to test you guys out of this first half of this unit on Wednesday. What it's basically on is we've done 5.2 through 5.6. We've done just the basic algebra stuff. Okay. We've done all just the factoring, leading term coefficients, ones, leading term coefficients, not ones, solving, getting your zeros, completing the square, quadratic formula, all that fun stuff. The second part of this chapter, or unit if you want to call it that, deals with all the graphing. So it's just a very easy breakpoint. The secondary part of the chapter we start up then on Thursday, and we're going to start doing our graphs and models and stuff like that. I have something kind of fun for Friday. I don't know how it's going to work. It might work. I hope it works. So we're still playing that one by ear, so it'll be close. Like I said, the stuff that we're working on right now, it's straightforward. There's no, I mean, I can't throw curveballs at you with any, really with any of the stuff as we're going through here. As it gets into, like I said, as we get into the the graphing portion and some of the modeling, that's where things do get a little bit more complex because there's a lot of little rules. But hopefully by now you're starting to remember some of those things from way back in chapter 10 of your algebra book a couple of years ago of some of the properties of parabolas. And you're going to see some of that again today when we talk about the modeling of it within the word problems. It is not as complex as what you guys believe. So, the word problem stuff we're going to get in here. Oh, wait. Tom's in the lower corner. You can write. That's you. You can autograph it. You're sure. Aren't you? The orange vest is pretty sweet. I don't know. You probably don't want to write somebody else's name.
I'm surprised you haven't printed mine out.
Oh, that's right. I do that. I'll do that later. No, I didn't get that. It might have got scanned. I haven't seen. I've looked at the So, word problem. When you're dealing with quadratic word problems, what I want you guys to see, what I want you guys to look at is how these things work. Let me ask this to start with. What do the graphs of parabolas look like, quadratics? Yeah. A bowl. They're up like a cup.
Down like a frown.
Or down like a frown. You guys agree? Okay. Now, when you're dealing with quadratics, there's a couple of ways to write that out. Remember, it's the ax squared plus bx plus c. Those were our quadratics, okay? Now, in order for one of them to be up like a cup, what was that leading term coefficient? Positive. Everybody remember that? Okay. So this is when a is positive, and this is when a is negative. Everybody okay with that? Now, do you remember what these points, what this point is called? Or this point? They're what? No. It's a vertex. But in terms of quadratics, point of something. Yes, it's point of importance. Yes, it is. Now, look at this one. Can you get
Climax.
all right. Can you get any higher up than that?
No.
Can you get any lower than that?
No.
Maximum, minimum. Dun, dun, dun. This is a maximum value. This is a minimum value. And you're right, they lie on the axis of symmetry. Okay. Now, the other thing that happened within graphs of parabolas is that we've been doing a lot of this. What are those called? Those are dots.
The zeros.
The zeros. Coordinates. Those are the zeros, all right? So we've been working a lot with that stuff. Now, what we do in a lot of the word problem stuff is that you're going to be finding maximum values, minimum values, according to what your zeros are. Let me show you a very easy example, and I believe this is out. Oh, I didn't open it. This is in your book. It's on, I forgot that on page. 258, 259. It's one of those. And I'm going to walk you through how you set up and solve a problem that has a maximum via quadratic model. All right, so you have a website, woohoo, and you're selling music subscriptions. You're Pandora before Pandora was Pandora.
Napster.
You were Napster. Napster, you weren't selling stuff, you were just giving it away for free. Kind of hard to be a business model when you're just giving stuff away for free. I don't think that was anyway. So here's what's happening. Your subscription price is $16 a year, and you get 30,000 people to subscribe to it. For every $1 increase in price, you lose 1,000 subscribers. So let's just think about that. If I charge $17, I'm going to lose how many subscribers? 1,000. Okay. If I charge $20, how many subscribers would I lose? 4,000. So the relationship there is that for every X value I add to the 16, I'm subtracting 1,000X from the other. Do you agree? Now, since this is a quadratic model, that means I can set this up as 16 and 30,000. Those are my two starting points, if you will. And they said that for every $1 increase to your subscription price, you lose 1,000 subscribers. So what do we know about quadratics? If I can set them equal to 0. Now the other thing that I'm going to do here is use my calculator. If I'm looking at this with my calculator, first thing I want to do is, before I even type it in there, I'm not going to bother foiling this out because there's no point. The calculator will do it automatically. So there's no point in trying to foil that out. Yeah?
Why did you set those up like that? Like what formula is that?
It's not so much a formula, it's just kind of how it makes sense in your head. For every $1 you increase your subscription price, you lose 1,000 subscribers. It is a quadratic model, so you're going to have two terms. One thing starts with this, the other one multiplies with this. That's just the section, that's it, that's all it was. It's not that you had to know that it was going to be linear or quadratic, or you had to come up with it. It's telling you it's going to be quadratic, you can get that. That's actually a really good question. A lot of these types of problems, they're going to give you some model. They'll say the trajectory of the golf ball follows this pattern. How long is it in the air for at this height or whatever? Yeah, you're making parabolas. Or there's a problem tonight. You're going to talk about Big Bertha the cannon in World War I.
It could fire shells incredibly long distances. The time for shell to be modeled by y equals negative
Kablooey.
0.0196x squared, 1.376x.
Thanks, Clay.
That's good. That's all you can say.
Anyway, so in this case, they told you it's quadratic, so you're just going to have two terms. All right. There's no point to foil that out, but if you just look at your values, what would your leading term coefficient be? Positive or negative?
No, negative.
Be negative. In this case, it's a little bit backwards there. The x values are on the right there. It would be a negative something x squared. So I know that this curve, if you will, I know that it has two zeros. One of the zeros is where? It's at negative 16. Remember zeros? That's all it is. Okay. I know I have one zero at negative 16. My other zero is where? 30. Just at 30. So I'm going to show you guys how you can model this stuff out with your calculator. This hasn't changed, guys. this hasn't changed from the problem before where it was x minus 2, x plus 5 equals zeros. What are your zeros? 2, negative 5. Numbers are bigger. Same stuff. Same stuff. Okay? Numbers are bigger. Now, when I set this up via the calculator, figure this out. I'm going to go to my y equals screen, and I'm going to put in the y equals exactly those two terms in parentheses. I'm not going to FOIL it, because if I FOIL it, I'll screw it up. 16 plus x. 30,000 minus 1,000. X. And I look at my graph. Now, as of right now, you can't see it. Most of your graphs are set up as a 10 by 10 window. Do you know how to check your window? There's a window button. There's a window button. Now, here's the reason why I took a second earlier to figure out my zeros. I know that if I was going to look at this graphically, negative 16 is here, and 30 is here. So I know that the graph's got to go like this. Are we okay with that?
Yeah.
That's the only reason why I figured out those zeros, so that way I know how to adjust my window.
So, what would you?
Well, if your zero is at negative 16, I might want my negative value to be at negative 20. You know, a couple away from it, so I can see it better. I do the same thing with maybe 40 on the other one.
What should we do for y?
Well, look at it.
It's really big.
It's really big.
Gigantic.
Yeah.
It's pretty large.
Now, we know it's got to go way up there, right? Okay.
100. That's big.
What's the back column?
Window.
Just window?
Now, if you, what'd you use for your maximum? Oh, I think I said there it is. Oh, you just got the outer parts? What's that?
How do you get that graph?
All right.
See that? No, you don't have it. You don't have one. You didn't put the formula in. That's, you have the white. Sorry, no wonder. Now, yes, ma'am.
Are there ways to do these kinds of problems without graphing them?
What I'm trying to get at here is a very simplistic way to show it with the graph, because it does, when a lot of our problems that we're going to do later on don't have real clean numbers. So the process of using the calculator it makes your life easier. Okay, I'm using an example right now that is very easy to find clean numbers. I'm going to show you an example here in a minute that doesn't have clean numbers. Now, I'll tell you one thing: you have to change it to something very, very large for your maximum. I put it in at like 600,000. I think that's about right. Okay. Change your Y maximum to be about 600,000. The only reason I know it's that from trial and error, and I've taught this class twice today. So we've done this problem a couple of times. Okay. Now, it does look like a parabola.
I said that's a big parabola.
Look, it looks like mine.
Kind of.
Oh, it's totally.
That's not what mine looks like.
That's not fair. You can air yours.
If you're getting a window range of an error, that means one of two things has happened. You might have a sign flipped where the x or y. You might have like your x minimum greater than what your x maximum should be. You might have to reset some of your dimensions, if you will. Okay. Now, what I want you guys to understand here is that this parabola is down like a frown, which means that top point is the maximum. Now, there's a button. Hit second trace. Calculate, where it says calculate. There's a button on there that says maximum. What I want you to do is show you how this works. If you go to your maximum, okay? Now, what it's asking you is to place the left boundary. What the calculator is looking to do is that there is this curve, somewhere in here is your maximum. It's asking you to place a boundary to look from this side and a boundary to look at this side to find the maximum value between it. You want to be to the left of your maximum, you want to be to the right of the maximum. All you do is use your arrow key to move it over so that it appears to be I'm to the left of the top point.
Does guess mean that's the maximum?
I'm not there yet. Okay? Once I hit that, it then automatically asks me for the right bound. So I go to the right of the curve. It doesn't matter where you wind up, as long as you're to the right of that peak, if you will, and hit enter again. Now you're saying guess. I don't know. It's 65 degrees out. I have no idea what guess means. I really don't. Seriously, I don't know why it's there. I really don't. So don't pay any attention to it, and you just hit enter one more time, and it'll give you your maximum. Second coming. Second trace. Now, here's what I want you guys to think of. It's asking for dollar increase. How many dollars increase? Well, 6.99999 is how many dollars? 7.00000 is how many dollars? 7. Okay. You're going to have a little bit of rounding error to think about what's going on. So what this is telling me is that if my x value, if this value here is at 7, that's the maximum amount that I can, maximum dollar amount more I can charge without having the most revenue. Because the question was, how much is the maximum you can charge? Well, $7 more than 16 is how much? 23. So the maximum amount that I can charge is $23, and then my right, but my revenue. There's my revenue. $529,000 is my revenue. Because this problem was written out as. Oops, let me scroll this back up. You have that many subscribers. That model tells you what your revenue is going to equal. That's your maximum revenue. When you add $7 to your 16, it gives you that much revenue. Okay? The calculate button on a calculator helps you to find maximums or minimums. Yes, there are other ways to do it. Okay? This so happens that there's a very nice numbers, very nice solution that you work with. I want to walk you through another one that's a little bit weird to get it to go. All right? But before I do that, most of these problems, you're always going to have to reset your window. God bless you. God bless you. One of the things that I tell kids to do with their calculators, because when you go to science, you go back and forth, if you drop it or you have no idea why something's coming up as an error message, you want to remember how to reset these. To reset these calculators, you do two things. Second plus sign 712, second plus sign 722. If you do that, it's kind of like that Achoo button on your calculator. Okay? It's how you reset it. Earlier in the day today, people were having problems where their domain keep coming up as errors. They couldn't figure out what was going wrong. They couldn't figure out what did they do in their window that it wasn't showing it correctly. So we just reset it, and then we just start over. It's a very nice way to reset your calculator. Yes, sir?
On the calculator, above a workshop, is there a letters? Do those have any purposes?
Those alphanumeric buttons. You can. There are. Are you taking physics? Anybody taking physics? I know that in physics you guys do some programming in the calculators, the 84s. I know Mr. Smith does that, where you guys can do some of the trajectory modeling and stuff. And he'll help you guys write programs to do some of the work. Yes, sir.
Is there a plus or minus button on this?
No. There's a plus and a minus button, but not a plus minus button.
There should be a plus minus.
I'm confused.
So
Totally not be close minus button, I mean like.
what I want you to do is put this in your y equals. Oh, I forgot it.
You didn't know that? I think you
What I want to do here is I'm going to put this into my y equals 12x squared minus 25x minus 7. And I know I have to change my window real quick. Okay. I just put my, if you reset your calculator, it should go back to a 10 by 10 automatically. Okay? If you go back to your, if you go to your calculator and you do that, when you reset, it should automatically go back to a 12 by, or a 10 by 10.
Is it a negative 10 by 10? Oh,
Now, when there's a couple of ways of going about trying to find where this is. This one isn't as crazy to find the vertex or your, sorry, your minimum value as the other one was. If you look at this one carefully in the graph, if you tilt it just right on the screen, you might just
I'm picking it up. I am picking it up.
What?
You know how hard it is to keep a straight face when I say that? I get someone in every class. This is great. I know. If you tilt it enough, you might see the curve.
She's still
The fact that it took you 3 times going. All right. Anyway, in this,
At least 5 of us.
I know it's awesome. So in this case here, what are you going to change to try and visualize it better? The y maximum or y minimum? Minimum. So you can tell right off the bat, it's probably not too much further away. So if you go to your window, change your y minimum to maybe negative 20. Okay. Whether it's negative 20, negative 50, it should still work. Okay. So here's what I want to do. No matter where your window is set at this point, if you go to calculate minimum,
What did you change the minimum to?
it's like negative 20, negative 25, somewhere in that neighborhood. If you go to your minimum now, that 3, it again asks you for the left boundary. So you want to be to the left of where the minimum's going to occur. My cursor right now is all the way up at 0. I'll just get it a little bit closer. It doesn't really matter, as long as you're close. Then I scroll around to the right side of it. See how the cursor's there now, as you go through it? Guess again, I don't know. And now this is an example where it's a crummy vertex, but it's still getting your stuff there. Yeah.
So we never have to like try to figure this stuff out without calculating, right?
Oh, you
We'll
will.
always figure out.
No, you will. I'm just saying, this. I'm just showing you that sometimes there will be times that it's a lot easier to do it without it than there will be times that they're easy to work with it. What I'm trying to get at is just kind of showing you guys how the zeros and how these things all work out. How do you press the buttons just to find some solutions here? Now, if you factored that, it's going to be a real crummy factor, which means it's going to give you crummy zeros. That's just all it is. All right. Yes, sir.
What about this equation right here in the example?
Which one?
The one that says x equals 30 plus negative 16 over 2.
What section are you in, sir?
An example 8.
Okay. What did they do here? They factored out 1,000. What did I do here?
No, but can we use that equation right here?
That's what we did.
Oh.
The only difference is that you started at 16, I added $1. Instead of starting at nothing and adding 16. You see what I'm saying? I just wrote it backwards, that's all. That's all. It's the same thing. Okay? It's the same thing. Yes, ma'am.
So going back to the calculator, what's the flip that for?
It's just telling you where you are on there. Right now it's asking you to go left down,
Yes.
which means you want your dot on the left side. Yep, just keep scrolling until you see it on the left. Yep, there it is. Hit enter. Now scroll back around and to the right. Okay. Hit enter. In this case, it's just, I'm just trying to show you guys where it is. Usually, when I'm rounding stuff, I usually go 2 decimal places, just so you get the idea. This was just, how do you use the calculator, okay? Now, the other one I wanted to look at here,
If we're rounding to 2 decimal places, will this one become 1.06 is the x? Because then I hope I did that.
I have 1.04 for mine.
How did you do that?
Now, Clay, what happens sometimes here, since this is not a very nice, clean, factored one, you get zeros, but you're going to get crummy numbers, crummy decimals. That's why you're getting crummy axis of symmetry. That's why it's weird like that. Okay. Now, the other thing I wanted to talk about when we're walking through with some of these problems is that remembering parts of parabolas again. When we're dealing with stuff that's in section 5.6, they talked about a model with initial velocity. There's a difference between dropping something
And drawing something.
and throwing something. What's the difference? There's something behind it. This is just, I velocized it.
Raptor.
So what's happening here, we're also working with forces of gravity, but we're dealing with stuff that has an initial velocity kick to it. So there are a couple of problems. There are a couple of problems in 5.6 that use this generic start of a model. Every initial velocity problem in a vacuum, we're not dealing with wind resistance or anything here, always has the same idea. Oops. The types of things that you're going to get, and tonight's stuff is very straightforward. They're all going to kind of use the same sort of model with this here. A lot of the word problems that deal with quadratic functions, you're going to get the model. You'll have to figure out what's the maximum, what's the distance, things like that. All right. Knowing what parts of a parabola are when you graph something makes your lives very easy. The 2 models we're talking about here is object dropping and an object with velocity. I don't have any problems for you guys tonight that have just the object being dropped. The velocity ones are basically, you're either going to have upward velocity, a downward velocity, or a horizontal velocity. It's going to be given to you, okay? It's going to be given to you. For example, what these things are standing for, let me pull this all, I'll pull this all up here. It's right in your book. Clear out it all. What these things are standing for are initial velocity and initial height. It's in your book. It's right in your book. Each one of these problems uses that same basic model, and they're going to give you some sort of information. For example, if you are, if you kick a soccer ball from the ground, what's the initial height? Zero. If you're heading the soccer ball, what's the initial height?
Your height.
Whatever your height is, or what if you're jumping? What if you're, how about this? What if you're a diver? If you are a diver,
Then you what?
It's all of her problems. What about scuba diving?
Oh, you're a good drawer.
You're a good speaker.
I speak good.
Drawer.
You're a good speaker.
Okay?
Good artist.
If you're a diver, you have an initial height of this that you're going to go.
That's me.
Hopefully you don't bounce.
Blue cock is so high.
Wait, do that again.
And how he bounced? Yeah, you should. That's bad. If you dive off the diving board and you bounce, bad things.
Like a
Take the
trampoline.
Why does it bounce? I forgot Mr. Murphy.
Because this is a spring.
We should play shuffleboard.
Oh my God, I want to
Stay back up there.
Okay, so if the curve is down, that is something negative and that might be like, I don't understand how.
If the curve is down, that means that it's down like a frown, which means that your x squared term is negative. Okay? Think about anything that you kick, throw, or drop. It's going to have a downward component. What goes up must come down. That's why all of those are parabolas that are down like a frown.
Whatever goes down must come up.
Well, that doesn't work because gravity.
Because gravity.
You know.
Yeah. So what'll happen with these? Yeah, Cliff.
Do you remember that old TV show? Not old, like 2012. They had the celebrity couples dive off. Like,
Yes, that was.
And they would always get the bad guys to jump off. They like flop around all around.
And you went like this.
Yeah.
Now, what'll happen in a problem like that? Just to give you guys an idea. It so happens I have a diving problem.
Cliff diving.
Let me show you how this starts out. Okay? Before I give you guys problems here. In July of '97, way back when, the first cliff diving world champions were held in Switzerland. They performed acrobatic dives from heights up to 92 feet. Suppose the cliff divers jump from this height with an initial upward velocity of 5 feet per second. How much time does he have before he dies? No, it's not even close to it. Because this is, you're using a projectile model. It's using that, no. Once again, if you're dropping, yes, you have initial velocity going up and out. This is why I'm saying you got to pay attention to the model here. Negative 16, was it negative 16t squared?
Let's draw a picture. Yeah. Oh, it's
Initial, this is a constant there, that negative 16t squared. Initial velocity. Okay. What we're looking at here is, well, he's not dropping, he's jumping up and out. So notice how it says it has an initial upward velocity. Would that be a positive velocity or a negative velocity? Positive. So you're starting out, you have your height. Your height was 92 feet. He's jumping up and out. So your initial velocity is that up 5 feet per second. So this is going to equal 0 because it's a quadratic. Negative 16t squared plus 5t plus 92. Again, now you're back to the point of why do I want to use my calculator? Because I'm sure as hell not going to factor that. See what I'm saying? You can, absolutely. Right? What's up here? Oh, this stands for initial velocity, original height, if you want to think of it that way.
So just put this in the calculator to solve it for us.
It'll give you a graph of what it's looking like, what you're trying to do here is figure out how long you get before,
Wait, what's
that's your time, okay? So you're trying to figure out where time is going to equal what? 0. You're trying to find your 0 where that's going to cross. Because at this point, if you think about this, this parabola would come all the way back here. This is just your starting point. If you get negative time, that means you went underground and he's probably really, really dead.
Really?
Okay. Let me give you a couple of these to try for tonight. I got a couple of sections worth.
This assignment is tough.
Do we have a review?
This assignment is
No.
tough. I listened to it, but I just like.
What I want to do here is section 5.2, 5.5, 5.6. This is 98, 101, 85 to 90, and 75 to 80. You're going to find out, I forgot what page numbers are off the top of here. You're going to figure out real fast that a lot of these are really, really straightforward. There's not a lot of trick involved here. It's a matter of using that last group in 5.6 is going to use some of those initial velocity style problems. The ones in 5.2 are like, if you sell something for $100 and you charge $5 more, you're going to sell less of them. So it looks like the ones we were doing earlier. And the ones in the middle are working with some area stuff. They're giving you the area, you just got to find X via a geometric shape. Okay? You should be pleasantly surprised at how quick some of these are going to be. Okay? I don't remember what page numbers. Those are the sections they're in. I don't remember the page numbers. I forgot to write that down. They're on the website already. What page numbers they are? 262. All right. This is 262. What's 5.5?
If 5.6 is 295.
Hey, can I send a request back now for tomorrow?
A lot of folks sell, but my house will let me.
You just can't put something,
So we
right?
have the test on Wednesday. Is there a new calculator test or?
No, this is going to be a music calculator.